It's coming. Yep, I see it.
Okay, so I tried to share the whole screen rather than just Simio. So here's your model. And so what I did when I looked at it, I noticed a couple things that I want to clarify. And then I did a little sample model for you to show you, I told you about task sequence. But I want to make sure that I understand what's going on before we talk in too much detail. So when I look at your incoming orders, I look at something like you're going through this process of granulation, compression, coating, and then you're going through some kind of packaging operation.
Correct.
And in each one of these, so if I pick granulation and I look over here on the processing time 0, because all of the processing actually happens inside these add-on processes.
Correct. So it grabs 3 resources.
Yeah, so if I jump in the add-on process, I think I was doing granulation right here. And so you have this series of seize, delay, release, seize, delay, release, seize, delay, release, corresponding to doing a setup, doing the processing, and then doing a cleanup.
Correct.
And for each one of these sets of operation, the setup, the process, and the cleanup, you need a different resource, right?
Yes.
Okay. So a pretty common setup. And I can see down here that you have these worker objects to do the corresponding operation.
Set up, run, cleanup.
Yeah, and so I have 2 basic things that I want to talk about. One has to do with how you implemented the 3 phases of the operation. Think about it that way. And the second has to do with why you're using worker objects rather than resource objects. Okay, so those are 2 things I want to mention first, and then we can circle back and talk about some of the finer points of the model. So I did a little sample model for you. You can see this, right? So I have in this one I have a setup operator, I have a process operator, and I have a cleanup operator. So similar to what you see in your phases. And so in this one, when I run, I have the operators move. So they start out at a home node. And when you're doing the setup, they go to the work node. When you're doing the process, they go to the work node. When you're doing the cleanup, they go to the work node. So they just circulate around. Nothing too interesting, but I think it implements the phases of, like yours, right? Okay. So the thing that's critical here is that's simpler is that instead of having the processes, what I use are called task sequences. So you can see if I go look at my processes, I don't have any processes in this model. It's all done through the server. And so when I look at my task sequence here, you can see, I'm going to move that over where you can see it. That using a task sequence, I can specify multiple tasks. So I can essentially have a network of tasks that correspond to this particular process that happens at the server. So in this case, I have process 10. Let me make this a little bit bigger.
I see it. No problem.
Yeah, so in process 10, you can see that I just used the default times. I didn't change any of the times, but I did say, hey, by the way, I need a resource to do this. I need my setup resource. There's my setup resource right there. And because I use worker objects, I said, I want this resource to move, and I want it to move to my work node here. And so that is what causes it to move. And then I have my process object, process step here. And this time I need my process object. Worker, I'm sorry. And for this one, I have my cleanup. So I did that 3 phases of setup, processing, cleanup, and each one required a different worker object. And in this model, I also had to move to a particular node. Okay, does that make sense? So instead of having the process where I did the individual seize, delay, release, seize, delay, release, seize, delay, release, I just specified it as a task sequence.
Oh, this is very nice. Now here I can also have breakdowns. For example, as I run the operation, I can have.
Yeah, so breakdowns, if you wanted to have breakdowns on the server, you could have breakdowns. You could have breakdowns in the individual processes. So there's there's a huge amount of complexity and additional features you can add to it. I'll just start out with the simplest description of how this works first, and then we can talk about all of the details.
And to get the flow time through this, say I just want to get the flow time through the through running the batch. I'm okay with the setup. I'm okay with the cleanup. I just want to see how long with the breakdowns, how long the process took. Will I be able to? I guess I could get that out of the straight trace.
Yeah, so if you want to know, well, if you want to know how long a batch took, I mean, it's just from the beginning. Well, I only have one server. And so in your model, you would have this replicated for each one of the processes, right? And so, yeah, you would just track for the batch what its time was. And you could track the time from start to end. You could track the time from start to the end of the first process or the second process, however you want. So none of that changes. I could go in and add an add-on process here. So I still have access to all of the add-on processes that you saw, right, that you use. So my add-on process triggers are all still there. The only thing I did was I just implemented that three-phase processing within the server using task sequences.
This is cool.
So I also have a second model for you. So I have the same model essentially, but instead of workers, this time I use resources. And so if I look at my task sequence, the task sequence is identical, except for the fact that I don't have a move, because the fundamental difference between using a worker object and a resource object is the worker object can move, right? And so the resource object, so if I run this, you can see the difference is they're changing color. So I'm doing the setup, process, cleanup, setup, process, cleanup, exactly what we did in the previous one, but you just don't have any worker movement. So if you're not going to animate the workers moving, it's going to be more efficient to use the resources rather than the worker object. Otherwise, it's identical. And the last thing that I want to show you, I have another model here because task sequences are actually much more, they provide much more functionality that I've demonstrated. So what I did was I created one that just shows, okay, suppose I wanted to do parallel tasks. And in this one, I left this note saying, okay, this doesn't really make sense because you couldn't do processing and cleanup at the same time. But suppose that you had a task network where you did parallel things. So in this case, what I set up was I have setup that happens first, and these two things can happen in parallel. So when you run this, you can see that these two are turning green at the same time, which means I'm doing those two tasks I'm starting those two tasks at the exact same time. They're finishing at different times because the times are random, but they're starting at the same time. And so if you
how do you do that?
How you do that in the task sequence is that I just, in this case, I have the same number. So if I look at this task sequence number,
20
10,
and 20.
Yeah, and I have 20 and 20. And so when you implement task sequences, you have three different ways to define the network. You can either define it using task numbers, which is what I did in this case. So the 20 and 20 say, okay, well, those can happen at the same time. Or I can use immediate predecessors or immediate successors. So if you think about a graph representation, I can have immediate predecessor nodes or immediate successor nodes. And so you can define it that way. And so you can have an arbitrarily complex process. And so let me just show you one thing. If you look in the help, there are two really good help articles about this. I just go to task sequence. And so if I look at the basic task sequence, refresh here, the basic task sequence tells me what it does. But then if I scroll down and look at the discussion and examples, it tells me all about this and how I have, this example. This is essentially the one that I did for you, where I have task sequence numbers 10, 20, 30. And then if I want to use the immediate predecessor, then it's, 10 for 20 and 20 for 30. If I want to use immediate successor, it's 20 for 10 and 30 for 20. But this really becomes important when you have more complex sequences like this one, for example, where I have two parallel, and then one here. And so the task sequence, by doing, you can still use the three methods, but some people like me find the immediate predecessor or immediate successor representation a little bit easier to see. The key here is this allows really complex processes. And so like some work that we did for, an airplane manufacturer in the Northwest of the United States that you might have heard of, we have task sequences that have 200 tasks. So you go to one server and you do 200 tasks that are in this great big combination of parallel and sequential and that kind of stuff. And so all of those tools are there for you. And so it just makes it a more convenient way to do it than by always using the process method. So even though the process method that you did works perfectly, and so if you implemented the task sequence method that I'm showing you and compared that to the process method that you did, you would get the exact same results. It's just a little bit easier here.
No,
And
this
it
is much
becomes
cleaner.
it comes even easier, which if you look in the help, there's a SIMBIT that shows you how to do this, is that you can map these to data tables. So I can map the entire task sequence to a data table. And so I could do this in Excel and bind it and all of the other things that you get when you do, when you use tables rather than hard coding it. So all of that capability is there. It just makes it really a lot more flexible.
Oh, this is really cool. Wow. Okay.
So
now,
that's
one other question. This home node, work node for the for these guys to cycle. That's a basic node basically that I define as.
Yeah, these are basic nodes. If you look at the worker object, you have a property that says what's my home node. So I specify the home node. And then you have what's called the idle action. And the idle action says, what do I do when I'm not working? And so the default is park at the node. And so what would happen is everyone would park here at the work node because they don't do anything else, right? So if I set the work action to, which is, the park at node for all three of these, what you're going to see, oops, I didn't mean to do that. Let's see, park it, reset that guy, and then reset this guy. What you're going to see is they'll all move to here, but then they'll just stay there, right? Because once they're there, they're idle. Even when they turn idle, they don't move.
They're not going to go.
So I set it to return to home just so you could see them move. But you can envision a situation like in your case where you have multiple processes where you might share setup operators, for example. Then you can show them moving around if you have that scenario.
Nice idea as well. Oh, this is great. I think I will redo the model like this. That's much
I'm going to send this to you. And the last thing I was going to ask you is, in your license, do you have the academic RPS license, or do you know what your license type is?
Quickly look.
If you go to the support ribbon right here, it will tell you under license type.
So I look at help, or no? I look at.
You go to support ribbon.
License type. It says academic design.
Academic design. That's a bummer because you don't have academic RPS, but this is something you could request if you want it. So let me just show you what that gives you really quickly. If I go to the planning tab here, you see, I can say, okay, we'll create the plan. And you can see what it did is it created me this nice Gantt chart. Let's see if I can zoom in a little bit. It shows exactly what all of the objects are doing, exactly what's constraining what. And so it has at the resource level, exactly what each resource is doing and what's being constrained here. So you can see that I'm being constrained here by, because I'm waiting for the setup operator. I can also see for each entity what the entity did. I can see, in your case, I think these are manufacturing orders that you did. You can see exactly what they're processing through. And so it just gives you a really nice way, even if you're not doing scheduling, which is what RPS is designed for. It gives you a really nice way to communicate the model and to also verify the model to make sure that it's doing exactly what you think it's doing.
This is really cool as well. Yeah.
And so you get this essentially for free if you have that license. There are a couple things you have to do, which, if you want to get that license, I can show you in detail. But basically, you just have to enable logging here. And then for each one of the objects, you have to go into the advanced option and say log resource usage. When you log it, then you have all of this complete capability. So if you're interested in doing this, I would suggest that you email the academic people at Simio and say you'd like to get the academic RPS license. And then I can also get you access to a couple of the training things that talk about specifically how to use it. But it's really useful even if you're not doing scheduling applications.
Yeah, that looks very nice. I mean, it's yeah.
And there is one more thing I was going to show you. I don't know if you know this, but let me pull your model up that I noticed. One little simple thing here. I'm going to zoom this up here. And I noticed that you use in your process, you use a lot of notify steps so that you can print messages and see what's going on. So there are a couple there. Two things that I wasn't really sure if you were aware of. One is if I turn off the model trace, right? So I'm not tracing, but I leave the model, the trace window open. I can do that through the project home. Then your notify steps show up, but none of the other trace messages show up. So if you just want to see the notify steps, just turn the trace off and it will eject your notify steps.
Excellent. No, I left everything on because, as I was saying, these supply chain wizard guys, they're basically going into the Excel file, collecting the trace, and then transferring those to their interface. That's why I left everything on. But yeah, this is
can be really
much cleaner.
Helpful in debugging too. You know, and the other thing I was going to point out is that if you go to the notify step, for example, or any step basically, and you can set this color attribute. And so if I say set this one to blue, it shows up as blue here, but it's also going to show up as blue in the trace. I don't know when that one's going to show up, but if you
I didn't know.
Yeah, when I do models with notify steps, I usually have different notify steps have different colors. So when I look in the trace, I can immediately pick out the notify that I want. So that's something that turns out to be pretty useful.